was called Using Machine Learning as a Material to Generate and Refine Aircraft Design Prototypes. So as you can see, this was obviously precursor building into my PhD. I actually wrote this paper at the end of 2022, so it was before my PhD started, and it was right at the cusp as we were starting to see these first bits and pieces of exciting generative AI that was sort of consumer ready, I suppose, or accessible to laymen such as myself, at least at that point in time. So in this paper, we're exploring the role of generative AI as a design material for prototyping new aircraft designs. Our design-led research used Stable Diffusion, which was a text-to-image generator, which I'm sure most of you have probably heard of now, but at the time it was not something that many people had heard of, to prototype these aircraft. Stable Diffusion is a deep learning text-to-image generative AI model. It is primarily used to generate detailed images conditioned on text descriptions, otherwise known as prompts. And again, when I was talking about this last year, there were a lot of people sitting in the audience who were kind of like, what is this? But I'm assuming probably a lot of you probably quite familiar with text-image generators now, probably quite familiar with this art of prompting. So I want to show you this image to start with. And what maybe, you think it might be of, maybe who you thought authored this image. So when we sat down to write this paper, we obviously knew that we were going to use Stable Diffusion, we were going to use it as a material, but getting sort of a baseline feel or handle on what it could do, and exploring with that tool was, that was like a lot of research, that's where you tend to start. Now, I'm assuming most of you see the characteristics of Da Vinci in these images, okay? And that was essentially I suppose, the artist we were using, or the creative author that we were using. But the output in terms of what we were trying to design here, and it might be difficult to see here, but it's actually an air vehicle. So if we look at these images, maybe it makes a little bit more sense. We've obviously got Da Vinci on the left. I'm just going to put a note in here that I'm definitely not in any way interested or for defence work, but with a lot of these large language models and these text image generation models, the training is really fundamental. And Stable Diffusion, when we started using it, was the end of 2022. You're looking at what was prevalent in media at the time, and unfortunately the conflict in Ukraine was just starting to kick off. There's a lot of talk about these new systems that were being deployed, and the air vehicle you can see on the right is called a TB2, Bayraktar, which is a drone. The reason why I had to use this was because I knew that the AI model probably had a good handle on that because it's using a lot of training data from news. And what you can see is that there's characteristics, there's obviously very strong characteristics of Da Vinci here, and you can see these characteristics of what it thinks a drone looks like. And depending on the models you use and how well they're trained, you will see that sometimes they have a very good handle on certain vehicles, certain products, certain concepts, and sometimes when the training is lackluster, it really misses those key fundamental aspects. So we launched into Stable Diffusion, we started experimenting with it to get this baseline of, okay, how do we use the tool? For us, we were obviously using it in a browser, which makes it a lot easier to work with, and exploring, let's just get a sense of this and what can it do? And as you can see from these first iterations, it was very basic sort of outputs. So obviously, it's trying to get a baseline of what the tool's capable of, but also how we're going to make it work for us and do what we want to try and do with it. So to realise the full potential of text-image generators, such as Stable Diffusion, one must develop their skills in prompting generative AI models. And this is obviously referred to as prompt engineering. We know this term fairly well now. But what if we approach Stable Diffusion slightly differently? Instead of treating Stable Diffusion as a tool to create, we treated it as a material, as the material that we were working with. And this allowed us to frame prompt engineering as the tool that would shape our material to create our aircraft prototypes. So the prompt engineering was essentially the chisel or the planer, and Stable Diffusion was the timber that we were shaping. So working to this notion of using Stable Diffusion as a material, we adopted the design theory of reflective practice, whereby designers conversely reflected with their design materials. So it implied that we reflected on the design material that we were working on, make a move to change the material, and reflect again, this time on the second iteration of the material to design. So we conducted this design-led research to explore, document, and analyse how Gen AI used as a design material by using Stable Diffusion to generate and refine aircraft design prototypes. So our data included the text prompts, the prototypes we generated, and the reflective conversations between us, the designers, and the AI-generated prototypes. And so then we began to try and create some novel aircraft prototypes. And we decided to work from two different lenses. So we were taking, obviously, aircraft and this idea of biomimicry to try and create some novel, interesting outcomes. And our initial experiments focused on understanding how to engineer prompts to generate viable prototypes. Typically, a text image generator like Stable Diffusion or Midjourney will generate 4 prototypes in about 20 seconds. So obviously it's fast. And the aspiration of this research was to perform this research experiment with minimal human interference or contamination. So essentially, let's learn how to use the tool and let it do its thing and try not to interfere or contaminate as much as we could to see how far it could actually get you. And to physically prototype would also mean that we'd have to be cognizant of what I've sort of coined as I was doing this presentation, the maker's hunch. So when you've got experience in making, as some of us in this room have got a long history of making, is that you tend to have a bit of a hunch about, okay, this is what I'm trying to make and this is how I think I would make it. Probably fed from past experience, things that you've seen, research you've done. So we started off, and you can see on the left-hand side, we've got essentially our list of prompts that we were using to build our prompt and some of the outputs. And at the start, we were just quite methodical. These are all the bits that we want to try and get out of this design. You can see we worked through iterations, and at the start, we were not having a huge amount of success. I was looking at a lot of this stuff thinking, oh, I don't think this is going to go very well. But as we started to refine our prompts, we started to break into some territory that looked a little bit more fortuitous. And you can see that in this set of outputs, we're starting to see some of these key things we're looking for. So we're seeing these elements of laser cut components, which again, that maker's hunch, that's what I was thinking. If I can get something that I can laser cut, I can work with it, I can make it. Engineering drawings. So often in engineering in general, but often in aerospace, you'll see 3 views of an aircraft. So you get a sense of what it looks like from the top, the side, the front views. It was like, again, if I can get 3 views, I can see what this thing looks like. That will help feed the prototyping process. Obviously, I need adequate detail. So after we had sort of got that initial run, we then moved to maximising variety with minimal input. So to do this, we utilised a matrix, minimise the keywords used in our prompts, instead playing with the pairing of keywords to maximise the number of prompts. So with 3 animal references, so we had pelican, hummingbird and bat, and 3 prototyping techniques, origami, laser cut, 3D printing, we initiated 9 experiments which produced 81 prototypes. Just look like this. And this was actually a really useful experiment because it helped us better understand where the shortcomings in the training of the model was. If we look at this one here, you can see there's definitely bat in those concepts. You can see that there is that aesthetic of a bat. And that prompt line at the bottom was bat airplane, okay? Whereas if you look, say, in the top right, which is supposed to be a pelican airplane, I'm struggling to see the pelican in that, okay? So this matrix was quite useful for us to sort of situate where its knowledge and its knowledge gaps lie. And also during this process, we found that using fewer keywords actually resulted in better fidelity, essentially. So better detail, feasibility, and more accurately actually reflected the intent of the prompt. And a lot of the research that I've done since then, and some of the students that have been in our studios, we actually find that You know, if you're using Midjourney and you put in a prompt sequence which is a paragraph long, Midjourney is probably only listening to 6 or 7 words in that prompt. It's very little detail it's actually paying attention to. And so the more keywords you add actually can tend to give the opposite outcome, make it more abstract. The next experiment we decided to run was to take advantage of a process known as blending. And blending lets you take an image and a prompt and add those together. So we took something off the shelf. I did a lot of error modelling when I was a child, which is where a lot of my tacit knowledge for this subject comes from. So taking plans and going, okay, can we integrate these plans into our process and see what happens? And these were the outputs that we got. And as someone who's spent a lot of time looking at plans and understanding things, suddenly my eyes started to light up a little bit because I was like, okay, now we're starting to get somewhere where I've got things that I can work with. You know, I've got a top view, I can understand what the plan form of the wing looks like. We're starting to get detail on the ribs. And we've got all these different outcomes, which is really interesting. Funnily enough, you can see in that first line, prototype 2, depending on the parameters that you're using, you could push it too far one way or the other, and suddenly you start to lose, or one side of the input overrides the other. So you've got an image and you've got a text prompt, and you're essentially trying to balance those two elements. So it appeared that Stable Diffusion could rely too heavily on the image to produce the output aesthetics, and then integrating on blended elements of the text prompts, bird, biomimicry, feather into that prototype, depending on the weighting, would give you varied results. But buoyed by these results, we decided to close the loop. So instead of taking an external image prompt, try and use something that we'd actually generated with Stable Diffusion previously, which is what this experiment was. So obviously had a very simple prompt, plan drawing of laser cut bird airplane or airplane. We got some outputs, took that and then inserted that into the second part of the experiment where we're using that to blend between the same text prompt with that image. And what you see here, which was, again, eyes lit up a little bit, was you can see that we're getting a development of that first iteration starting to happen. Instead of just all these varied ideas, which you see in the top row, we're getting these different developments of that core idea, which brought us to our final experiment. So we generated 28 prototypes using the following text prompts comprising of 15 words, which was a kit of laser cut parts of an airplane inspired by a bird, engineering drawing 3 views detail. And then of these 28 prototypes, we chose one of those iterations. Number 16 was the one we took. We prioritised images that appeared feasible for physical prototyping using a laser cutter. These prototypes exhibited elaborate structural detail while consistently recasting the shape and layout of the primary elements of the airframe. And then we obviously took number 16 and then developed on that image. And the beautiful thing about this is in this slide you can see 2 phases of the design process. You can see ideation and development. This all happened in 5 minutes. This was all done with 15 keywords, and that was it. Which, again, maybe doesn't feel as spectacular 18 months later, but at the end of 2022, I was like, wow, this is pretty amazing. We then decided on a couple of the elements that we liked. We took 4, and then we actually produced those outcomes. Laser cut from balsa and assembled them. And of course, being a designer, didn't want to just go for something straightforward. It had to be one of the more complicated designs, which I then developed further. And sure enough, if it'll let me, oh, technology, there it goes. And this is obviously where, you know, the aviator, the experienced maker, the pilot all feeds into that, where I was leveraging that, that knowledge and experience to actually be able to take this thing and make it fly. was really interesting. There was a couple of real key fundamentals that came out of that. And two of the big words that I take away from it was seeding and curation. We're at this point where we can use these tools to seed our ideas and to actually curate what comes out of it, and the role of the designer can actually shift. So, you know, these AI processes are really offering these opportunities to look at what our design practice and design process looks like and see what the future potentially could hold. Thank you very much.